trawl gear already staged on the stern deck for the first set.
A pelagic factory trawler is not a fishing vessel. It is a floating food production facility that collects its own raw material. The trawl nets are pre-rigged on the stern, 400 meters of net staged and ready to deploy at the captain's order.
The vessel reaches the target coordinates at 0340 Plum. The school is at depth and the trawl deployment order is given.
The warp cables pay out from the winch drums as the trawl descends toward the school. 2,000 feet of cable for this depth setting.
The net settles at the target depth. The vessel comes to trawling speed at 4 knots, and the soak begins. Below the vessel, the trawl net is moving through a school of Alaska Pollocks that numbers in the millions of individual fish.
Sure is quiet out here today. Yeah, enjoy it while it lasts. Hauling's gonna be rough.
The vessel tows for 90 minutes. The codent is filling at a rate the captain reads from his catch monitoring system.
The haulback order comes at 0510. The winch drums engage, and the warp cables begin to come up at full hydraulic speed.
Keep that speed constant, we're almost clear. High tension reading on the warp.
The trawl doors break the surface first, the otter boards visible before the net, the first sign that haulback is nearly complete.
Slow down the drums. Too much weight. Copy that, slowing port winch. Keep it steady, she's almost clear.
The code end is lifted to the stern ramp on the vessel's hydraulic stern block. The shape of the net becomes visible under the water. The code end clearing the water weighs 60 tons, and the hydraulic stern block is rated for this load, but the strain is audible. Inside the code end, Alaska pollock are packed so densely that the individual fish cannot be distinguished at the surface.
Lower slowly, easy on the swing. All right, hold it right there, looks good.
The code end release mechanism opens from below, and the fish drop into the tunnel where the refrigerated seawater pump intake begins.
The RSW pump is not moving fish, it is moving a fish and seawater slurry, a liquid transfer at 30 tons per hour.
This is the moment that separates the factory trawler from any other fishing operation. There is no manual fish handling from net to factory.
The holding tank on deck receives the pollock slurry and separates water from fish through a rotating drum screen.
Check the pressure on the line.
Pressure is stable, we're good to go.
The first haul confirms 58 tons, nearly 50% above the target tonnage for a single trawl set on these grounds.
The factory hold receiving tanks are designed for a maximum of 80 tons of live pollock. The haul is pressing that limit.
The processing floor below receives the signal leaf, the haul is complete, and the heading machines start up in sequence for the full run.
The first Alaska pollock moves from the holding tank to the processing conveyor mentor. The factory clock is now running.
From the pump intake to the processing conveyor quantity, a single Alaska pollock is handled by 0 human hands unless a machine fails.
The processing conveyor runs at 200 fish per minute at full capacity. Zero hesitation between haul completion and processing start.
The holding tank retains a buffer of live pollock and chilled water. The factory can sustain maximum throughput for 11 hours on this haul.
The second trawl set begins at 0615. While the first haul is being processed below, the net is back in the water above.
The factory trawler's architecture makes this parallelism possible. The deck operates independently of the 3-story factory below it.
Below, the processing floor is now operating at full scale, heading machines, fillet lines, and freezer systems simultaneously. The size grader separates fish that the heading machine can process optimally from fish that will require a different configuration.
Off-grade fish, small, damaged, or low-condition individuals, are diverted to the Surimi line before the heading machines. The heading machine intake conveyor is filled to capacity. Fish are placed individually on the conveyor at machine pace. The heading machine operates at 50 fish per minute cruises. It has removed the heads of 40,000 pollock in a single 8-hour shift.
The head is removed behind the gills in a single rotating blade cut. The machine times the cut from the fish's body position on the conveyor.
The heads collect in a below-machine chute and feed directly to the fish meal processing system, as zero waste in this throughput model.
The headless pollock body continues on the conveyor to the gutting station noon. In some factory configurations, gutting is also automated.
The rotary gutting machine removes the viscera from each headless body in under 2 seconds, and the cavity is washed by a water jet immediately after.
The viscera from 400 tons of pollock feeds the fish meal and fish oil system, and a parallel byproduct stream that runs the full shift.
The raw corn, if the season is right, is removed as a separate step before gutting sowing, valued at $14 to $18 per kilo. The gutted and washed pollock body moves into the pre-fillet inspection station for Ricky. Condition is read by eye before the machine decision.
The machine throughput on this vessel is 40,000 fillets per hour. 1 heading machine and 2 parallel fillet machines. The fillet machine receives the fish belly down on a precision feed conveyor so position accuracy determines fillet yield. Inside a commercial pollock fillet machine, 12 individual cutting and positioning steps happen between entry and fillet. The first fillet panel exits the machine. Bright white, skinless, the fillet line is now running.
At full production, the fillet machine outputs 1 fillet panel every 1.2 seconds.
The machine removes the skin simultaneously with the fillet cut. A rotating drum skinner takes the gray olive skin in the same pass.
The skin exits through a separate channel below the machine. It feeds the fish meal stream alongside the heads and viscera.
After 40 minutes of operation, the fillet line is producing 3,200 pollock fillets per hour from 2 machines, and holding that rate. Each fillet from a pollock is examined in 2 categories, upper fillet and lower fillet. They are processed differently downstream.
The upper fillet is the primary commercial product. It carries the pin bones that the removal machine targets in the next station.
The lower fillet, there's the belly section gray, is thinner, and depending on grade, may go directly to the minced fish line.
The pin bone machine reads each fillet panel with an inline X-ray system. It locates every pin bone before the removal cut.
Once the X-ray data is processed, the water jet system fires in precise targeted bursts, removing each pin bone individually.
The pin bone removed fillet exits the machine, smooth, clean, no pin bones, the premium product format for the export channel.
Pin bone removal is the quality critical step on the pollock line prime. It is also the step most likely to reduce throughput when the machine requires adjustment.
The manual backup pin bone station runs alongside the machine. Experienced operators pull residual bones the machine misses.
The fillet QC station reads color, thickness, surface integrity, and pin bone status before any panel moves to the trim bench.
The trim bench squares each fillet panel dually. 4 cuts, consistent geometry, the block format that matches the retail and export specifications.
The trim pieces are not wasted. They are collected and routed to the minced fish or surimi input, alongside the off-grade fillet stream.
The squared fillet block goes on the portion scale, weight verification against the target specification before packaging.
The IQF stream accepts the smallest units, individually portioned fillet pieces that will freeze as separate items.
The block format fillet stream routes separately so full fillet panels are stacked in boxes for the plate freezer system.
2 streams, IQF portions and plate freeze blocks, feed 2 separate freezing systems simultaneously in the floor below.
Keep the line clear on station 3. We got a backup over here.
The crew works in 6-hour rotations pickerels. The machines run continuously while the crew rotates through rest and return.
The noise level on a full throughput factory fish floor is above 90 decibels. The crew wears hearing protection at every station.
The factory floor temperature is held at 2 degrees Celsius, cold enough to maintain product quality, cold enough to feel across an 8-hour rotation. The Surimi parallel line runs alongside the fillet line, and it never competes with the primary stream for input, but consumes everything the primary line rejects.
The Surimi separator takes off-grade pollock and mechanically separates meat from connective tissue and skin in a single screw press action. The Surimi paste from the separator is not the final product. It requires washing, straining, and refining before it becomes commercial surimi. 3 cold water wash cycles remove the fat content and dark components. The finished surimi paste is a uniform white protein extract.
The surimi refiner removes the remaining connective tissue, and the paste exits the refiner as a smooth, fully homogeneous white protein mass.
Surimi paste from Alaska Pollock is the input to imitation crab, fish cakes, kamaboko, and numerous structured seafood products worldwide. The surimi block is pressed into a uniform rectangular format and enters the plate freezer, the physical form of surimi in the global supply chain.
The row line runs in parallel to both the fillet and surimi lines in Corbin. It is the most time-sensitive product in the hatch today.
Pollock roe is one of the most consumed seafood products in Japan. It appears on the market as mentaiko, Alaska Pollock tarako, and flavored roe.
The roe skeins are graded A, B, and C by membrane integrity and color uniformity. So, grade A,
Grade A roe skeins are individually wrapped and vacuum sealed before them reach the plate freezer. The packaging prevents the membrane from dehydrating.
The W-wide but filled view of this processing floor at peak operation is the definitive image of scale in the global whitefish industry.
Every hour at this throughput produces 32 tons of processed product from the primary fillet line alone.
The trim bench operators work to a rhythm set by the machine. 400 cuts per operator per hour in a well-run production shift.
Ensure the temperature logs are updated hourly at this station. The flow rate seems slightly off.
After 4 hours of operation, the fillet count has reached 160,000 individual panels, exactly on the throughput projection.
In the Bering Sea, Alaska Pollock schools move in synchronized formations millions strong. The school is the unit, not the individual fish.
A single Alaska Pollock school in the Bering Sea can stretch for 3 miles in a single direction. The trawl net.
Alaska pollock are the most commercially important groundfish species in the North Pacific lice. The fishery produces over 1 million tons per year.
The pollock's synchronized schooling behavior is its primary survival mechanism, and the school confuses predators, not the individual fish.
The same schooling behavior that protects the pollock in the wild makes it the most efficiently encircled commercial species in the North Pacific.
Tool test. The Bering Sea pollock quota is allocated annually by N.O. Belay based on stock assessment, and the fishery has been managed.
The Alaska Pollock in this haul entered the fishing zone less than 40 hours ago often. The school has been tracked since the prior vessel pass.
The IQF tunnel on this vessel has been running for 3 hours to reroute. The fillet output from the processing floor is entering it continuously.
The IQF tunnel maintains minus 40 degrees Celsius in its interior, and individual fillet pieces freeze solid in 22 minutes.
Alaska Pollock in the open Bering Sea are in constant motion. The school never rests, it simply slows or accelerates with current and temperature.
The IQF frozen fillet exits the tunnel, individually frozen, hard, glazed with a thin water ice coating that protects the surface.
The pollock fillet in frozen form retains its bright white color and fine-grained texture. It is indistinguishable by...
The IQF output conveyor loads the frozen pieces into bulk weigh-fill cartons. A 100-kilo carton fills in under 4 minutes at this output rate.
An Alaska Pollock school can evade a trawl by diving below the net. It is the school's collective response to the approaching gear.
The plate freezer accepts the full panel fillet blocks, stainless plates compressed around the carton for 2.5 hours at minus 35.
The plate freezer produces a compressed rectangular frozen block, the format used in every whitefish supply chain globally. The frozen block exits the plate freezer, a uniform rectangular block of compressed Alaska Pollock fillet, each layer separated by a thin liner sheet. The frozen pollock fillet block is the standard unit in the global whitefish trade. From this point, it enters every fish in...
The plate freezer output line runs to the carton sealing station. The frozen block goes into a wax-coated master carton before cold hold entry.
The surimi blocks exit the plate freezer on a separate output, 10-kilo blocks, pure white, the commercial unit for the surimi market.
The surimi block exterior is marked for grade code. AAA, AA, and A designations indicate the fat content and whiteness index of the batch. The cold hold of this vessel has a capacity of 1,200 metric tons at -22. It will fill over 4 consecutive trips.
The cold hold is organized with a palletized stacking system, 15 cartons high per pallet layer, pallets locked to the cold hold floor structure. 6 hours into the production run, Blorton, the cold hold has received 160 tons of finished frozen product from this single haul.
The row product from this haul is complete. 900 kilograms of grade A and B Alaska Pollock roe.
The roe carton is the smallest in weight and the highest in per kilo value from this haul. It is the first to be booked by the Japanese market agent.
The heading machine is on its third blade set of the shiftos. Dull blades increase the torn flesh rate and reduce fillet yield.
A blade change on the heading machine takes 4 minutes. The fillet line upstream buffers product during the pause.
The freshly bladed heading machine comes back online, and the throughput restores in 90 seconds. The cut quality immediately improves.
The second haul code end is visible at the stern three. The trawl that was set while the first haul was being processed is now coming back.
Slow the pump rate down now, we are almost full. Throttling down the RSW pump.
The factory operates on a push-pull model. The processing floor pulls from the holding tank at the rate it can sustain.
The row station closes at the 10-hour mark. All row has been extracted and packed, and the secondary crew reassigns to the fillet QC position. The Surimi refiner has processed 32 tons of off-grade pollock and trim in 10 hours, producing 11 tons of refined Surimi paste.
The plate freezer load for the Surimi line is at 90% capacity, and the last Surimi blocks of the haul are entering the freeze cycle.
At hour 10, the total production value of this haul is tracking at $460,000, freeing the projected value at haul end. The IQF tunnel has been running without interruption since hour 1, and it has frozen and released 38 tons of individual fillet pieces.
The cold hold is now 60% full, 240 tons of finished product against a 400-ton input haul. The second haul will not be fully processed until the first haul is complete too. The factory cannot sustain dual peak volume inputs simultaneously.
The processing floor night crew begins their rotation at hour 12. The day crew has been standing since 0340, and the handoff is systematic.
The night crew takes the line at full throughput, and the machines do not know the difference between a day crew and a night crew.
At the 14-hour mark, the second haul begins feeding the processing floor. The first haul holding tank is nearly emptied.
The fillet machine throughput rate at hour 14 is within 3% of the hour 2 rate on. Machine performance holding above expectation.
The total fillet count at hour 14 is 268,000 individual panels from 2 machines.
The IQF frozen fillet cartons are filling the last available pallet positions in the starboard cold hold section.
The plate freezer block output is ahead of schedule. The final pollock block batch exits at hour 15.5, 90 minutes before the expected window. The last Surimi block exits the plate freezer at hour 16. The Surimi line is shut down in sequence, and the equipment begins its flush cycle. The processing floor crew begins closing down stations in sequence as each product stream completes forts. The heading machines are first to stop.
The fillet machines stop at hour 17 Dapplery. The last fillet panels already in the IQF tunnel when the machines shut off.
IQF tunnel continues running until the last panel has completed its freeze cycle. The tunnel does not stop until the last product exits. The last IQF frozen fillet piece exits the tunnel at 17 hours and 40 minutes. The IQF production cycle is closed.
The cold hold doors close at hour 8 and 3. Every fish from the first haul is now a finished frozen product behind these doors.
Dawn breaks over the Bering Sea as the processing crew exits the factory floor, and the factory that ran all night is going into its cleaning cycle.
The external view of the vessel at dawn gives no indication of what happened inside it over the last 8 hours. It looks like any other ship.
The factory floor must be certified clean before the second hall's holding tank can begin feeding the processing line. No overlap of halls on the floor. At 0620, the processing floor passes inspection, the second hall holding tank opens to the intake conveyor, and the second production run begins.
The vessel has now been in continuous operation for 20 hours. Trawl, haul, process, clean, process again.
The second production run through the processing floor will take 14 hours for the second haul of 42 tons.
The total operational commitment for one complete factory trawler trip is 21 to 28 days at sea.
By day 3, the cold hold will be at 40% capacity. By day 10, it will...
The vessel's cold hold capacity of 1,200 tons defines the trip length minimum. The operation ends when the hold is full. The fifth haul of this trip brings the cumulative total to 400 tons of pollock processed in 72 hours, exactly on target.
The Bering Sea at this latitude is gray in winter, and the clouds, the water, and the deck are all the same shade of industrial gray.
The crew that left port 21 days ago will return changed by the industrial scale of what they have sustained.
The pollock fillet block that exits this cold hold will be portioned and further processed at a shore plant before it reaches retail format.
The surimi block from this vessel will be purchased by a processor in Tokyo or Osaka, shaped, textured, and sold.
The IQF fillet from this vessel will become the fish fillet in a school lunch program in 3 U.S. states. The volumath of commodity whitefish.
At a shore processing facility in Dutch Harbor, Alaska, the cartons from this vessel will be reprocessed into...
The block fillet arrives at the shore plant and is retempered light, brought from -22 to -5 for processing into portion formats.
The sea of Alaska Pollock fillet portions that exits the bandsaw line in a single day defines the scale of a commodity fish supply chain.
The retail pack is the final format, an individually wrapped or multi-pack tray of Alaska Pollock fillets, sealed, labeled with a store code.
This retail pack traveled from the Bering Sea factory trawler to this shelf in 19 days, the cold chain held at every link.
A shopper selects the pollock fillet Erzig. It is the most purchased commercial fish in the United States by volume, yet most buyers cannot name the species.
At a fish and chip restaurant, the pollock fillet is the fish behind the batter, the identity hidden, the volume essential.
The pollock fillet hits the fryer oil at 180 degrees. The bright white flesh becomes fully opaque as the protein sets in the heat.
The surimi product travels a different path. From the vessel's surimi block, it becomes structured seafood in factories across 3 countries.
The fishing grounds of the Bering Sea have produced Alaska pollock continuously since commercial harvest began. The cold hold of the 150-meter factory trawler is now full. 1,200 metric tons of Alaska pollock product in 3 categories, ready for port.
The transit to port from these grounds takes 42 hours at full steaming speed. The cold hold holds temperature. The crew rests in rotation during transit. The machines are secured, the cold hold monitored, and the next trip's planning begins.
Okay, that's 250 cases here. Code 749 Alpha matches the record. We are good for port arrival.
The port of Dutch Harbor processes more fishing vessel offloads than any port in the United States alone. The infrastructure is built for this scale.
The 150-meter factory trawler approaches the dock at 0540. The dock crew is staged and the offload equipment is pre-positioned.
The mooring lines go over, and the cold hold offload begins within 8 minutes of the vessel reaching the berth.
The dock forklift extracts pallets from the cold hold, 1,200 tons offloaded in 6 hours, with 3 forklifts cycling continuously.
The reefer warehouse adjacent to the dock accepts the product directly. No temperature gap between the vessel hold and the shoreside cold chain.
The raw product offloads separately from the bulk fillet and surimi roti. a dedicated cooled transport vehicle for the 900 kilograms of roe.
All right, that's the last one. Sign right here.
The processing floor is cleaned and recertified between every haul. The sanitation certification is renewed before the vessel departs for the next trip. The net drum is restaged with fresh net material through. The factory trawler's next departure is scheduled 48 hours after arrival.
The factory trawler does not wait for market conditions. The trip schedule is set by quota allocation and the production calendar, not price signals.
温度確認が異常なしです。在庫に入力しましたね。
The surimi from this trip has been pre-sold to 3 buyers before the vessel even arrived at the dock.
The fillet block is sold on the commodity market. Price is set daily by the Whitefish Exchange. And the block from... The first reefer truck of fillet blocks departs Dutch Harbor for Seattle at 1400. A 46-hour drive with... The secondary processing line portions the fillet block into retail-ready units. The familiar fish fillet sold in...
The surimi from this vessel is processed at a surimi plant in Osaka, Kangapaku, where it becomes the structured sea fractalis.
The roe is processed into mentaikaiko at a specialty facility in Fukuoka. It will appear on the retail shelf within
3 product categories, 4 supply chains, 12 countries, 1 80-ton haul from a cold gray sea.
The factory trawler completes its second trip of the season in the same operational pattern. 5 hauls, full cold hold, 48-hour port turnaround. The fishing quota for Alaska Pollock in the Bering Sea is set at a level designed to maintain the stock above the minimum viable biomass threshold.
The factory trawler's quota allocation is reviewed by the manufacturer, the vessel's investor, and the regulatory authority before every season begins.
The quota is not the production target for insurance. It is the ceiling above which the operation cannot legally go.
The net maintenance crew inspects the trawl net between every haul. 12-meter repairs on damage from the seafloor are standard.
The RSW pump seals are replaced every 14 operating hours, and pump seal failure during a haul transfer would lose the entire code end.
The heading machine blade count is logged every shift. Blade condition directly controls fillet yield, and fillet yield is the primary revenue variable.
The IQF tunnel refrigeration system has redundant compressors. One failure does not stop production.
On a factory trawler, the engineering crew is as important as the processing crew. The machines only produce value when they are running.
The pressure differential is still unstable at the intake.
I'm showing a fault code on the diagnostic tool.
I think I found the loose connection in the wiring harness.
Keep them coming, load the bottom row. Watch the stack, move it faster.
The 21-day trip data package becomes the input for next season planning. Every deviation from target is...
After 8 hauls across 4 trips, the vessel has processed 112,000 tons of Alaska Pollock in the season 2, its full quota ceiling. Uppers. The vessel enters the maintenance yard for the mandatory off-season service. Hull, machinery, refrigeration.
The factory that ran inside this hull, the machines that processed Alaska Pollock at 40,000 fillets per hour, is now silent.
In the Bering Sea, the pollock school that this vessel partially harvested has reconsolidated, and the stock assessment will show it above baseline again this year.
The crew returns to their family's crash, some for 2 months, some for a single month, before the call for the next season's crew list.
Lisa, the factory trawler will return to the same grounds next season. The same temperature breaks, the same school aggregation areas. In the Bering Sea, the Alaska Pollock is schooling now blown, preparing for the herring-following migration that will bring it back to the harvest grounds.
The retail shelf that sold Alaska Pollock fillet this season will sell the same product from the same source next year, Bazan.
The Surimi plant in Osaka
has already contracted the next season's supply.
The purchase order is placed before the vessel returns for its first trip.
The Fishery Management Authority sets the next season's quota based on freshly completed stock assessment surveys, DOE. The number changes every year.
A factory trawler that processed 400 tons in one operational window will do it again. 8 times next season. The vessel's net enters the Pollock School at 0440 on the first set of the new season. The cycle begins again without ceremony.
The pump starts at 06:18. The fish and seawater slurry moves from the code end to the holding tank in the same automated sequence as every prior haul.
The heading machine starts at 06:35, and the first pollock of the new season enters the machine at exactly the same throughput as the last pollock of the prior season.
The fillet machine has been serviced, recalibrated, and tested. The first fillet panel of the season exits at 06:48, bright white, within specification. The IQF frozen fillet from the first run of the new season looks identical to the last run of the prior season, and the system produces a consistent product.
The first cold hold entry of the new season happens at hour 4. The pallet count begins again from 0. The vessel that returns to this dock next season will carry the same 1,200 tons of lorries, and the season after that, and the one after.
The pollock in the Bering Sea is a renewable resource precisely because it has been managed as one.
The machines in this vessel's processing floor will run for another 15 years before the vessel itself requires major structural work.
The captain of this vessel has made 43 trips to these grounds over 18 years. The Bering Sea is his professional landscape.
The deck boss has separated the trawl gear from the purse seine of the prior vessel. Each trip to these grounds has its own memory in his hands.
The heading machine operator has been at this station for 7 seasons. At 40 fish per minute, he has overseen the decapitation of a factory floor. QC supervisor has read hundreds of thousands of Alaska Pollock fillet panels. She can read a fillet's grade in 4 seconds by eye. The trawl on this vessel has visited these grounds on 62 occasions in 11 years. The Pollock School meets it on every return. The Bering Sea pollock fishery employs 2,000 Americans on the water and 30,000 more in shore-based. The economic contribution of the Alaska pollock fishery to the U.S. economy exceeds $1 billion annually.
The vessel's production this season, 480 metric tons per trip, 6 trips, 2,880 metric tons of finished product.
The fillet yield across the season averaged 36% of input weight herd, within 1% of the vessel's design performance specification.
This spike represents the variance from the target in May. The systematic analysis points to the equipment calibration schedule.
So we adjust the maintenance cycle?
At the season's close, the factory trawler's gross production value across all product streams totals $14 million.
The cold, hard math of the Bering Sea pollock fishery. 4 voyages, 62 hauls. The vessel maintenance team begins work the moment the crew leaves. The factory that ran inside this hull has 8 months to prepare for the next season. The heading machine is disassembled for its off-season service. Every blade, bearing, and sensor tested and replaced to specification before the next season.
Watch the salvage line right here. Yeah, I see the tear. Pass me the shuttle.
The Bering Sea in winter is empty of factory trawlers for 60 days. The quota year closes, the stock rebuilds, and the regulatory cycle resets.
Next season, the factory trawler returns to the same grounds operate. And somewhere in the Bering Sea, the Alaska Pollock School is already there, waiting.
The vessel clears the harbor at 0530, heading north, the Bering Sea ahead. The Pollock School's confirmed by